Hello students, in a previous clip we have discussed about addition, subtraction, multiplication, division and power rule for our some of the errors. Now we will discuss about its explanation with some of the examples. So let's say we have a length that is called as a 5.7 plus or minus zero point 0.1 centimeter and a breadth is equals to 3.4 plus or minus zero point 0.2 centimeters. If I want to discuss about its error uh, of a rectangular area, so what we are doing is that you are aware that in front of you I have placed that L and B. First of all, I am leaving up to you what you will do in such type of example where you have been given that rectangular error. So what you will do is that your length breadth is given. So first of all, it will be followed by simple notation a equals to LB. First of all, we have a 5.7 multiplied by 3.5. So we have a calculator available to us. So I am just calculating that 5.7 multiplied by 1.4, which may give me 7.98. So 5.7 multiplied by 3 sorry, it is a 3.4. So we have been given data 5.7 multiplied by 3.4, it may give me 19.38. So it is 19.38 centimeters square. So this is my area given to me. Now I want to find it out delta A by A. So you are aware about the data where we are just putting that delta L by L plus delta B by B plus or minus delta L equals to zero point 0.1 divided by 5.7 and plus delta B equals to zero point 0.2 divided by 3.4. So which may give me plus or minus, I am taking that LCM, 0.34 plus 1.14 divided by 5.7 multiplied by 3.4. So I'm just multiplying and just putting those data for you. Delta A by A is equals to, I can have a plus or minus, that is called as a 1.48 divided by 19.38. I want to find it out delta A. So delta A equals to plus or minus 1.48 divided by 19.38 multiply by A. So I can have a delta A is equals to plus or minus 1.48. You can just put it in terms of a round it off. So I can just place my data A plus or minus delta A is equals to 19.38 plus or minus 1.48, and that is called as a centimeters square. So this is how you can calculate your first of all data, and that is called as our in, area in terms of length and breadth. Now we want to just conclude that second example for us, that is called as our D, which is given to us. Let's say our distance is 13.8 plus or minus zero point 0.8 meters and time 4.0 plus or minus zero point 0.3 seconds. We have to find it out speed and it's a percentile error. So what we are doing is that first of all, you are aware about speed is equals to distance upon time. So distance we have is a 13.8 divided by 4. It may give us 3.45 meter per second. That is my speed. Now I want to just find it out my something more part, that is called as I want to find it out delta S by S is equals to plus or minus delta D by D plus delta T by T. So I can have a delta S by S is equals to delta D by D from the data is called as a zero point 0.2 divided by 13.8 plus, and time would be 0.3 divided by 4.0. So after calculation I may get delta S by S is equals to plus or minus 0.0895. I want to find it out delta S, so I'm just multiplying S with this data, so it may directly give me delta S equals to plus or minus 0.3087 meter per second, and you can just represent like previously we have shown for delta A by A. Likewise this one, this is my S and this would be my delta S. So you can arrange in the terms of like that. So this is how we can calculate, first of all, the very simplest to simple type of example. Now I have placed one good example for you, and that example will lead you some of the basic queries. First of all, you have been given that our specific resistance of a wire is represented by the rho, and its equation is given. It is called as pi r square by L. Be careful in exams, you are not been given such type of formulas, because after 12th you will be in competitive exams, and at that time you have to remember all those equations. So first of all, as per my data, I am mentioning that rho is equals to pi r square capital R by L. And you are aware that whenever such type of data is given to us, we are not in position to use our any constant, so pi can be cancelled out. So only the thing we have to just calculate is error in the row is equals to small r square capital R by L. Now I want to find it out. Error in the terms of delta rho by rho is equals to 2 times delta R by R plus delta capital R by R plus delta L by L. So I can have delta rho by rho is equals to plus or minus, I am placing plus or minus 2 times 0.01, because I have been given that a small r value which is 0.01, divided by 0.26, plus delta r's value is called as a 2, divided by 30, and I have 0.01 divided by 75. So I can have a delta rho divided by rho is equals to, I can have a plus or minus 0.1436. This is the data or error in the terms of a rho, which is called as a specific resistance. And for the percentile error or percentage, what I am doing is that 0.1436 multiplied by 100%. So I may have a 14.36 percentage. This is the percentile error for my given data. So this is how you can calculate your errors. Next has been given to me is called as a x equals to a square b raised to 3 c plus or minus d. My data is called as a equals to 2%, b equals to 1%, c equals to 3%, and d equals to 4%. I want to find it out error in terms of x. So what I am doing is that putting that x and in the terms of a delta x by x. You are aware about the power rule. Whichever power is coming in the multiplication, so I can have a delta a by a plus 3 times delta b by b plus delta c by c, and plus root is called as a raised to 1 by 2 power delta d by d. You can see your data here, it has been given in the terms of a percentage readily available to you, so there is no need to convert in the terms of multiplication. So what I am doing is that a 2 multiplied by 2 percentage plus 3 multiplied by 1% plus 3% and plus 1 by 2 multiplied by 4%. So it may give you 2 and 3 5, 5 and then 6 and 1 7, and that would be led to the 12 percentages. So this is called as a error in percentage of x, or for x we have just found it out. So this is how you can calculate your different type of errors. Now we can just go to the another good example, and that is called as same example which we have done. The third one, which is called as pi r square by r, but data is somehow different. Here we have a 0.26 plus 0.02, I have 0.26 and 0.01. Length is something different, I have mentioned to you. So what you have to just do, first of all, just think about the data which is given to you and what they want from you to solve such type of example. So very first thing is that what I want is that define those things which has been given to you, and define those things which we have to find it out, or neglected parts we can neglect such data. We have been given first of all formula rho is equals to pi small r square capital R divided by L. So I can just say that my pi part is going to be cancelled because it is the constant part. So I can have formula rho is equals to small r square by R and divided by L. Now as per our notation we want to just find it out error in the terms of a rho and percentage error for that. So plus or minus delta rho by rho is equals to plus or minus 2 times delta r by r plus delta capital R by R plus delta L by L. So I am just now putting those values which has been given to me from those data. Delta R is equals to 0.02, 0.26, capital R is 2 by 64 and delta L by L is 0.1 divided by 156.0. So whenever you are putting such type of data, be careful because there are minor change may lead to your wrong answer. So at that time you are not in position to remove your errors. So don't make any type of a human error. As you are now familiar with the different type of errors, I have just placed now data in front of you and that is called as 156.0. So delta rho by rho is equals to, now give me that plus or minus this data will be 0.04 divided by 0.26 will give me 0.1538. 2 divided by 16, that is called as a 1 upon 32, and which may give me 0.0312, and that is called as our point is only our area of concern 0.000 and 64. So I may get plus or minus delta rho by rho is equals to plus or minus 0.1856. This is my first of all fractional error. I want to find it out in terms of percentage error. So percentage error, these are the short forms or abbreviation which are valid in any exams. So delta rho by rho multiply by 100%. Yes, in competitive exam there is no need to put such type of things. You can directly multiply 0.1856 by 100. So directly it may give you that 18.56. So this is the error in our data which is given to us. This is called as a r pi r square and L equals to rho. So such is the examples where you can just go and find it out our different type of errors. One of the favorite examples of mine and a good example which may just try your metal, or I can just say that which may give you an opportunity to just think about what type of error you can create or it may lead to you, because it may give you some of the questions which has been solved whenever you will learn proper calculation in a differentiation part. So you have such type of data r1 equals to 100 plus or minus 3 ohms and r2 equals to 200 plus or minus 4 ohms. First of all we will discuss about series, which is very simple one. You are aware about such formula in 10th, r1 plus r2. So systematically directly you can just say that these are the initial data. So 100 and 200, so I may have rs is 300 ohms. Next one is called as a delta rs. I can just place plus or minus over here, it is also valid. Delta r1 and delta r2. So plus or minus delta r1 is 3 plus 4, so I may have a plus or minus 7 ohms. So I may mention that r dash equals to rs plus or minus delta rs. So it may be represented as a 300 plus or minus 7 ohms. This is the simplest one. So you may say that, okay sir, in this example there is nothing that you can just say that is challengeable part. Yes, gradually wait for the time. It is right now 1 upon rp, 1 upon r1, 1 upon r2. Or you can say that whenever you have a two resistances in the numerator, you are going to go for the multiplication part, and the denominator you are going for the additional part. But what I am doing is that I am using this word Mentos khao dimag ki batti jalao. So I can just use that for the two resistances R of big brother divided by n plus 1. So whenever you have a two resistances, this is the ideal method, and I advise all those students to go for such type of method. Let's say I have a value of R1 is 100 and R2 is called as a 200. So big brother is a 200 and a smaller brother is a 100. So I can, instead of R of big brother, I will place that 200. So big brother is a 200. How many times it is higher than the previous one? Means 2 times. So I can place that 2 plus 1. So my final answer of parallel is equals to 200 by 3 ohms, or you can just say that 66.7 ohms. So this is how you can calculate. But yes, some people are very much habitual with the laborious method. So in India, India is a, you can say that, agricultural country, and if you want that, you want to be a good labor, you can go for such type of conventional method. But I wish that no one from the physical point of view, physics point of view, go in the labor industry. So always follow such type of very simple tricks. It may reduce your time whenever you are going for the competitive exams. So that was only a conclusion of my tricky part. Now this is the tricky part which is coming, that is called as R of parallel divided by R of parallels square. Whenever something is in the denominator and you want to find it out, it's a parallel part, always go in the denominator's square. This is the only complicated part. Same is the course of delta R1 divided by R1's square and delta R2 upon R2 square. This is the equation of resistors parallel. So this is the equation we have to follow, that is called as parallel, and this is the equation which may give you sometimes goosebump to the students because they forget that how to calculate all those data. So what I am doing is that calculating such type of part for you. Be careful whenever you are putting its values. We have already calculated parallel part, we will place it over here. Delta R1 we have, that is called as a delta R1 we have is a 3, delta R2 is 4. Be careful, in the denominator it is containing the square, that is why this example is very much important. Delta Rp is equals to, what I am doing is that multiplication of Rp square delta R1 divided by R1 square plus delta R2 divided by R2 square. I am just putting that delta Rp square is called as a 66.7 square. Delta R1 we have, that is called as a 3, and delta R1 is called as a 3, and R1 is 100, and that is called as it's a square. It would be 10 to the power 4. Delta R2 is 4 and R2's value is called as a 200 square. So by calculating it, I can get 66.7 square divided by 3, 10000, 40000. So by just putting all those data, I can say that delta Rp is nearest to 1.88 ohms. So this is called as a value of parallel. Now I want to just show in terms of our gradual representation. I am just putting that R double dash is equals to R parallel plus or minus delta R of parallel. So R double dash R of parallel is called as a 66.7 and delta Rp is called as a 1.88 ohms. So these are the classic examples. So with the help of your knowledge of addition, subtraction, multiplication and division, you can go and do such type of examples. So whenever you are in a query of addition, subtraction, multiplication and such type of power rules example, first of all, always I am giving you simple advice: always follow and thoroughly study its equations, its rules, and then go for the such type of example. It may clear your all doubts. Thank you.